All right, I'm just going to record the slides. Yeah. They can hear me talk as I'm going. Should be good.
You ready then?
Yeah. Yeah, I'm ready.
Are you guys ready?
Y'all ready?
Yeah.
Okay, my name is Lynn Bendixson. I just started at Sovrin about 6 weeks ago. I'm in charge of QA and IT and apparently in charge of setting up meetups. So we've asked Kyle to present for us today. He's got some stuff about agents. I'll let him go right at it.
Okay.
Oh, we got some snacks over here. Sorry, before you go.
Yep.
We have some snacks over here for anyone want some. And then in a little while, we'll take a break and some pizza will come in. We have some pizza and some drinks. So.
And I have a few stopping points. So this is actually a much longer talk than what's allotted for this time. This is the talk that I'll be giving in Switzerland. So I do have a question here so that I hit the audience here today. Would you guys prefer to see more high-level concepts or would you prefer to see more demos? So if you prefer more high-level concepts and more of a talk style, raise your hands. We've got a few, we got 4 or 5, and then who wants to see demos? Okay, we got 3. Okay, so we got a little bit of a consensus. I will do the talk very quickly then, and then we'll jump into demos just as a little bit of a practice run. This is being recorded as well, just the slides and then the microphone. So if you guys have questions, please speak up, and then I'll try and reiterate it because I'm going to share this out with a few people. As far as the talk goes, this is about Indy Agents. I'm from Evernym, Hyperledger Indy ambassador. And so I occasionally go and give talks, which is why I'll be in Switzerland. This is also a link to the slides. I believe this still works. I'll have to double check it. I actually just took these slides from a talk I gave 2 weeks ago. So I think it still works, but I will double check and make sure it does so that people who see the recording can go look at it. A little bit about me. I am a core developer in Indy. I touch on a few different places. Right now I'm heavily focused in agents, which is what this talk is about. I'm also trying to figure out how we get stuff into Indy SDK for people to be able to use and build agents, as well as I work on kind of the protocol layer to be able to communicate between things. And I jump over quite a bit and stuff like that. So if you have questions about Indy, I usually know it, or I can refer you to the person who does, which is usually Mike, because it's usually crypto questions. To cover the agenda, we're going to do decentralized identity concepts first. Like I said, we'll go over this very quickly. Then we'll jump through the Indy architecture, which is going over what the libraries are, what they're good for. We'll show a video for a demo use case. And then last, we will do how you get involved and some links in there so that people can go in and take a look at the slides. We'll do a video, and then I'll do 2 separate demos. There's a few different things to be able to do the getting started guide. So jumping in, with the identity model, we started out kind of like throughout identity systems in general, we started in a very centralized identity model way, which is basically when I want to interact with somebody, like an organization, I go interact with them, and then I have a completely separate identity and a separate persona to a completely separate organization. And we found that, that's worked and it's been built on standards, but it also does have its drawbacks. One of the main drawbacks being you don't really control your data, and it allows for basically disproportionate leverage when you're talking with organizations and stuff like that. So for example, we've seen many times Twitter will just go shut down people's accounts. That's because they're built on a centralized identity model. Next, we have what is referred to as the third-party IDP, or essentially the federated identity. This basically means there's one person who's acting as a giant middleman to be an identity provider for all the people who don't really care about identity. And so usually what that means is like your OAuth to like log in with Facebook or log in with Google. But ultimately you have a person who's sitting in the middle and who's answering these questions and who can censor you. So for example, One thing that I've done is I've used login with Facebook before, and then I use that to log into my apps. And as soon as I delete my Facebook account or disable it, I can no longer log into any of the other connections. And that's kind of an inadvertent consequence of this federated identity model. So last is the stuff that we work on, which is self-sovereign identity. And this is where you have basically a blockchain or a distributed ledger, which is posting your identity onto the ledger, or more specifically, an identifier, which has keys and endpoints so that they can get a hold of you and cryptographically contact you. And so the idea behind this is that you gain a lot more basically data ownership, negotiation leverage, as well as privacy preserving aspects from self-sovereign identity, because you retain the data and you get to decide who you are in what context. So moving forward, we've got decentralized identifiers, and these are one of the core pieces that goes on the ledger. And so on the Hyperledger Indy ledger, what we're doing with them is we're actually using them to be able to identify who's issuing credentials. Most of your relationships, which is what you'll see in this agents talk, are handled through off-ledger DIDs, or they will be. That currently is not implemented, but that is in the works. So the question always comes, what does a DID look like? It's actually built on an RFC for 2141, which is about URNs. So we're using the URN syntax, which is basically you've got a scheme, a namespace, and then the name-specific identifier. And that name-specific identifier is random in all the DID method specs that have been used so far, and that's so that you have a giant namespace. In terms of mathematics, it's like, the number of characters to the exponent of number of spaces, so you have a giant trillion namespace. So this is what an actual DID looks like. So the idea behind this is you've got DID. To identify this as a DID, not HTTPS or something else. And then you've got the method of which you use to resolve the DID. So generally, this is an aspect that points to how which ledger it's associated with, or what is the method of resolving it. So for example, Ethereum has, I believe, at least 3 different DID methods. They've got ERC 725, Uport's got their own DID method, and then I believe there's Jolocom that's also built on it and using stuff. And so what that does is it takes the giant method-specific identifier, and it uses that as an input to then go figure out how I go and get the actual keys and the endpoints. An endpoint is just like a URL so that I can send a HTTP message, or it could be, here's my address so you can send me a piece of mail if you want. That's one of the nice things about it. One of the cool things that Hyperledger Indy focuses on, and a few other projects focus on as well, is you won't have just one DID. And that's to focus on this idea of correlation. One of the big things that we've seen about privacy preserving systems and what we have today is that you can be tracked like quite a bit. Like, it's amazing how much information you can pull out of these types of systems that we have today. And that's because we have common correlation points. So for example, all those random spam calls you get? That's because you have a single identifier for you, which is your phone number, and that gets passed around by everybody behind, and they sell it. And so that's how you get random calls that you're like, I have no clue who this person is. So what we're looking to do is solve this by creating a different name or a different identifier for each relationship. So the way that I kind of explain this is it's contextually unique, which means basically in this room, if I wanted to be identified by you guys all and correlated by you guys all, then I could be by giving a single identifier to all of you, or I could choose to give an individual identifier to each one of you. And that just means I give a different DID and set up a different connection. Hyperledger Indy is built around the concept of giving a different DID for every person, but there's some other people who are looking at it in group context as well. So there's a large variation of this. So moving forward next, we have verifiable credentials. This is kind of the way that we do things today. We've got issuers, persons, and verifiers, and persons is like me. And so the common context that people like to use for this stuff is basically like a wallet. So the idea behind it is if I'm going to the bar or something like that and I need to show them my ID, what happens is first I'm issued the credential. So the driver or the Department of Transportation gives me this driver's license and I now carry this. Next what happens is I go and present it. So if I'm walking up to the bouncer at the bar, I hand it to him and he goes and takes a look at it and he's checking to make sure all these holographic aspects work and stuff like this and make sure it's not a fake ID. He relies on basically his knowledge of what these IDs are supposed to look like and the security mechanisms to actually validate that. And once he's done that, he validates the credential and he decides, yep, this is good, and he allows you to pass. And so that's kind of the traditional workflow today. With the workflow for verifiable credentials and what we use, which is digitally, what you do is you register a proof of credential integrity and provenance. So essentially what that means is I take a DID that I have on a ledger, and it's associated with someone like government or a bank. And I'm going to then go into signing basically a schema, which is basically just like a JSON document of key value pairs. So in context of this driver's license here, it says my name. So it would say name and then my name. And so the schema doesn't have the actual fields like Kyle, Gregory, and Hartog. It has just name and then what should go in that name. And so that's going to then be signed by a key and put on the ledger as well. So we've now added two new things to the ledger. We've got schema definitions, and credential definitions. That credential definition is combining the DID and the schema so that you can then have it and associate a specific verifiable credential to it. So then what we do is we issue a credential using this credential definition and the DID that I actually had signed and put on the ledger. And I issue that to the person through this kind of flow process. Yeah, go ahead.
Between the schema definition and the credential definition. I think I understand the credential definition would be something like this is how a driver's license looks.
Yep.
What's the schema definition?
So the schema definition is actually, this is what the driver's license will look like. So it'll say name, address, driver's license number, issuer. Credential definition then adds a signature that says, yes, I will be issuing credentials with this schema. Yep, no problem. So then what happens, if we're going back to that bar example, when I present this credential, I'm going to digitally then send this credential to them using zero-knowledge proofs, which we'll walk into right after these slides, which is basically then going to validate the credential integrity and provenance. So what this is saying is, I'm going to go check to make sure this DID is actually capable of signing this credential. As well as I'm going to check with the fourth thing that we're going to add to the ledger, which is the revocation registry. So the idea behind this is you present a credential that says, here is this piece of data, and then you will also present a proof of non-revocation, which is basically saying, just like with my driver's license, I have this driver's license, but if I had that revoked for whatever reason, say I got too many parking tickets, and they're like, no, you can't have a driver's license until you pay those fines. They can actually do the same thing digitally here. Even though I possess this card, it may not be valid to the police officer or to whoever I'm handing it over to. So we have similar models to be done digitally. Yeah, go ahead.
In that whole chain data,
Yep.
data flow, where does your birth date actually exist? Is it in any of this data that's going back and forth yet?
It can be within this issue credential, or it's not within the issue credential. That is blinded and kept to yourself. There's also instances where you actually have to hand it over. So for example, when I am trying to present my birthday to somebody, the government already has it on hand, so they don't really need it from me. They can just issue it based upon what they have on hand. Whereas if I'm going to my bank and telling them what my birthday is, then I will actually need to hand it over so that they could validate it.
I'm talking about the voucher verifier.
Oh, okay.
When you present that credential to him,
Yep.
does it actually have real data in it?
You have the option to do either or. And so that's kind of the zero-knowledge proofs. In that instance where you're presenting your birthday, you do not need to present it because you can prove that you're over 21, which is what matters to him more. In the case of
Okay. You're going to go on.
Yeah.
You're going to explain to me how he verifies it.
Yep.
And the way I understand it is that you never present a credential. You always present a proof, right?
Correct.
Yeah. So you never are presenting the credential
Yep.
for your birthday. You're always presenting proof. You can prove your birthday is a certain proof. Yeah.
Okay. You got that? Yep.
This could be actually in the future probably, but what is the incentive for Verify to not have somebody actually?
So the main incentive for people, and I'm glad you asked this question because I normally try to cover this topic, is they no longer have the liability. If you don't have to hold that data, you don't have to be held liable because nobody's going to try and hack you. And so if you're just taking in credentials, verifying them, and verifying the proof is correct without actually taking any of the data, and you don't store that data, you can still store the proof credential, the credential that you used to prove, which has no valid data to it. It just answered certain questions to you, but you don't need to actually store the data, making you a very low value target to a hacker. And so that's the main benefit to a verifier. Moving forward.
The other reason is you could, as a prover, you could say, I'm not going to do it.
Yeah.
You have an option.
So yeah, it adds negotiation leverage to that aspect for the holder. So now, one little meta comment. I wasn't sure where to put this, so if you guys think it should go better before, please let me know. But the idea behind a zero-knowledge protocol is basically it's a method to prove that I know something without having to actually tell you. And so I have a slide that kind of explains that better, and it's actually this one here. I will jump back to the other one. It's essentially, how many of you guys knew the game 20 Questions? Okay, a few of you. So the idea behind 20 questions is there's an object, and what you're doing is the person is guessing that object, and depending upon the questions that they ask you, you answer yes or no. That every time that question is asked and you respond, that is a zero-knowledge proof. However, one of the caveats of zero-knowledge proofs, because they're not a silver bullet, is that if you answer too many questions, it can be guessed and you can be correlated. So for example, if somebody's sitting there and you respond 15 different times, are you over 21? Yes. Are you over 40? Yes. They can start to get, narrow the range of what the person's actual age is. And so this is where you have control over how much information you actually correlate. And so this goes back to the idea that you were asking about, which is the bar. With zero-knowledge proofs, I can actually prove to you that I'm over 21 without having to actually share my birthday. And so I can reduce the amount of knowledge that I have to share with you in order to satisfy, your needs and your regulatory compliance and stuff like that, which then helps both of us in the end. I get to keep my privacy, you get to reduce your liability. And so that's kind of the real benefit of these verifiable credentials. So moving forward, we've got what we call decentralized key management. And this is one of the really cool aspects of what we do in Hyperledger Indy and in the Indy SDK. So the idea behind this, and this is what the majority of this talk should be about, is agents, is they map to the real world like we have today. So rarely when I go to court, do I actually interact with the court directly. I have somebody acting on my behalf, and that's exactly what an agent is doing in a digital context. That's exactly what my browser does. I don't speak HTTP protocol, my browser does. Similarly, I don't speak legal jargon, my lawyer does. And so that's how it maps to the real world today. And what this does is agents are intended to basically act as a key management system for you. And so what it does is it makes it easier for you to actually manage keys and understand the relationships that you're doing while still getting the guarantees that keys give you from a cryptographic sense. And so that's why I kind of look at it and I go, we've essentially got this Jarvis here that's acting as our personal agent to go and manage these relationships and give us the certain guarantees that we want without having to sit here and do a bunch of math to be able to cryptographically verify everything. The other addition to the agents is that they allow for diffuse trust of keys. So essentially the idea behind this is no longer will I have a single agent that represents me. Similarly, O.J. Simpson didn't have a single lawyer who represented him. He had a team of lawyers. And with personal devices today, what we have we actually have multiple devices. You can see I have 2 sitting here right now. I should be able to interact with everybody using both those devices because they're both representing me to communicate my concerns. That's kind of the idea behind this. And so what it grants you is this idea behind revocation of devices that we don't really have a good solution to today. But Indy brings that new solution in, which is basically, if I want to, I can actually go and revoke one of my devices and say, even though you have all the keys and all the agents, I can publish to the ledger and say, hey, don't accept these anymore because I've authorized through one of my other devices that has been stolen or that has been lost or some other need behind that. So that's one of the cool aspects that agents grant you because we have all this complexity brought into these agents. Lastly, one of the cool things that it does is it brings about social recovery. So one of the things that we have right now that this is associated with is password forgotten. This is one of the awesome aspects about centralized systems is if I want to go, reset up my connection, I just have to go prove to them that I knew something about what was going on in the beginning when I first set up the connection, and I can go get re-onboarded very easily. In a decentralized system, though, that becomes very confusing. So what we have is something that's essentially like Shamir's secret sharing. It's a bunch of fancy math that's very difficult for people to do in person, but can be done by phones very easily that allows me to be able to actually go and recover all my backups and to be able to reset up my connection in a decentralized way. The cool thing about this, though, is I get to choose how I'm diffusing this trust. So if I want to choose 5 friends and I need at least 3 of them to be able to set up this connection and set up my connection and recover all my information, I can. But if I've only got 2, then I can't. And so what that makes is if a hacker needs to come in and steal all your information and they're trying to use that model, they have to go and approach 3 of your friends. And so you get to decide how you want to diffuse that trust, which is very cool because it's much better than the centralized model, which is actually the weakest link in the entire system where they just have to go and prove to the other party that they're you, even though they're not, and now they can impersonate you. And so you get to decide these things rather than the other company doing. Yeah, go ahead.
So does that mean every time I forget my password, my friends are going to get paid to see it?
So the idea behind this is that essentially that's a last resort type of thing. If you have all these other agents, so say I've got a phone and a laptop and some other desktop computer at home, I don't necessarily have to go to them to be able to recover it. What I can do is I can deauthorize one of my agents with my laptop. I can deauthorize my phone, and then I can go and reauthorize a new phone. And so then I don't have to reach out to them. However, if I lose all 3 of those devices, which is very unlikely because I've got a desktop PC sitting at home, somebody must have really been trying to steal my stuff, then I have that backup plan in place. And so that's kind of the idea behind it.
So your keys are distributed across one of those devices drops out.
So the idea behind this is that you actually have different keys for every device so that you can identify it. And so you actually have an even messier key management problem. But that's kind of what the agent is there for, to solve this. Yeah. Yep. And so it's supposed to basically act on your behalf. It's similar to the idea behind a browser. They're actually referred to as user agents today. I did see you had a question though.
I'm not sure I'm ready to formulate the question.
No worries.
The agent has, I guess, it was basically, but if one of those devices, you're kind of saying that a device has one key can now revoke another key.
Yep.
But you must be sure you're missing something you're saying, because then that's the same problem. You solve it. If one of your devices is compromised, then they can just revoke all your other devices based on the one that they have. It doesn't, that's not.
Yep.
It's not a solution. So I know there may be something missing.
That's actually the next piece of this. So it's rather interesting. One of the things that we realized very early on is that there's actually 3 axes and 3 planes to identity. And so this is the model that Jason Law actually came up with and has been a very profound insight in how we're developing and solving some of these problems. So the first access that you basically have is your relationships. And the key aspect goes back to the DIDs. That's how relationships are represented in the technical aspect is through your DIDs. You have different contexts and you look different to different people. And so that's essentially what this is saying is, to your sister, you're Bob, but to your Acme, your employer, you're an employee. And to your bank, you're just a customer. And to the USA, you're just a visitor. And you share different information with all these different people. And so that's the idea behind it is you should be able to control the information that they have. And so that's the first aspect of this, which is the relationship access. The next access is represented by the verifiable credentials, which is essentially the attributes access. And the attributes access is essentially what is the information, what are the actual fields of data? My name on my driver's license. What am I actually sharing with you? Am I sharing a property about it, or am I sharing the actual raw data itself? That's kind of the idea back to the over 21 example. I'm sharing just that I'm over 21, not that my birthday is actually May 27th, 1994. I had to guess because I was looking at issuance date, which is very similar looking. The third dimension is the agent's access. And so this will answer your question here in a second because we're going to actually show kind of how these planes interact. But the idea behind the agent's access is that you have multiple devices that are representing you. And so similarly, you have multiple lawyers who could represent you, or you could have, a CPA, accountant, a lawyer, power of attorney. You can have multiple ways that you can be represented in the real world. In the digital world, we need the exact same thing, which is our devices. Yeah, go ahead.
Something like your memory represents three-dimensional for example of that?
Yep. Yes. So that's actually this attributes agents plane right here, which is what we're going to get into is kind of how these planes represent the different aspects. So that's, I believe, in 3 slides. But the idea behind this is that with these 3 axes, you've now created 3 separate planes as well. And so we're looking at this in a 3-dimensional mathematical model. Hope I'm not losing anybody here. I think everybody knows this stuff pretty well, so I don't think so. But the idea behind the plane is essentially where the X and Y graphs basically cross, you're answering the question of who knows what about me, which is basically what information am I sharing with who? And that's represented in kind of this, which is basically with, my employer, I'm sharing my name, and with, my bank, I'm sharing, only my name and my salary. But I don't need to share my role. They don't care about, what my official title is and what my capacity is. And so I share different information with different contexts through that relationship and attributes plane. The next part of this is which proxies represent me in which context and how. So what this is basically relating to is the idea behind your bank. You have your CPA representing, yeah, go ahead. Relationship, yes, thank you. I did a little duplicate slide, so I will go and change that. So the idea behind this, and I don't like the word proxy, it's essentially which agents. Similar to the idea of, the lawyer aspect. The lawyer represents me in court. The CPA represents me to the IRS. The CPA doesn't represent me in court unless I got some messy IRS problems. And so they generally do not cross. And so that's kind of the idea behind this, is your agents manage these relationships, and that's what this plane is intended to represent. And so the way that this is managed is through what we refer to as the microledger, which is basically how do I establish what keys to interact with a specific person so that they can be certain that I am who I say I am, but I can also use any single device that I want. And so this is kind of one of the, under the hood things that agents are supposed to be managing for you and are built into agents. The last piece, which is the question that you had, which is which proxies can share what about me? And so this is kind of the idea behind, what kind of information do they actually, are they able to share? And so this goes to kind of the lost phone example. And so essentially what I understood that you're asking is, what prevents them from being able to revoke me? And so the idea behind this is that you have what we refer to as an authorization policy. And that authorization policy allows somebody the ability to deauthorize another device. And so if you set that up at the initial steps, then you can then say, I expect that this should be able to deauthorize this, but that should be able to deauthorize that. And so what you're doing is you're basically deciding, okay, my laptop or my desktop computer, I don't think anybody touches because it sits there for 6 months of the year. So I'm going to set that away as the thing that can deauthorize things the most. But if I want to, I can deauthorize that using 2 of my other devices. And so what I need to be able to do is take signatures from 2 other devices and be able to send a message to the ledger that says, hey, get rid of that other device. And so by setting up these cool policies, you can actually set up how you're able to control your information. I realized also, yeah, go ahead.
So I'm assuming that we have a one-to-one relationship between agents and myself. So my mobile phone, can my mobile phone represent multiple people?
Yes, it can. But how it represents multiple people is through different keys. And so that's why you have different keys that represent you. So if I'm trying to represent myself to Adam over here, basically I have a specific key for him. Whereas if I want to interact with you, I have a different key for you. And if I wanted to share that device and allow Mike to, he would have a different key for both of those interactions as well. So there would actually be 4 keys that are on that device, and you use them specifically. And the idea behind multiple people using the same devices is that they don't have access to each other's keys. So you actually give them 2 separate wallets and 2 separate agents. So moving forward, I'm going to run through this stuff really quick so that we get to the actual demo stuff. This is more about kind of explaining what's in the Hyperledger Indy. We are at 45 minutes too. Do we want to give a snack break or do we want to wait? Okay, let's just run through this real quick then. So the idea behind the architecture is we have basically 5 different aspects to it. There's also a 6th repo called the Hyperledger Improvement Project repo or something like that. It's referred to as Hyper. Thank you. I never remember the acronym, but the idea behind it is it's essentially an RFC to be able to make changes to any other aspect within the Indy project ecosystem. So the first part of this is the crypto part. The crypto part, as it's named, basically handles all the ZKPs and the signed state proofs. So if you want to, you can pull that part out and you can use that. And that's actually being consolidated with Hyperledger Labs by Mike here into a standardized Hyperledger crypto library.
Hyperledger Ursa now.
Yep.
It's a bear of a project.
So the idea behind this is that you'll have your CL signatures, which is handling all the zero knowledge proofs and stuff like that. Your BLS signatures, which is handling all your node validation between each other, and that's all done separately so that somebody else can abstract that and use just that part right there. Next, we've got the plenum consensus algorithm, which is based on an RBFT protocol. It's leader-based with redundancy checks, which is the redundant Byzantine fault tolerant. That's what RBFT stands for. Basically, what's happening is it's running a single consensus algorithm that's actually deciding what's going on, and then underneath the hood, it's running it as a backup to check that the actual one that's running is running as the most optimized solution and isn't running into failures. One of the cool aspects of this is that it can sustain a certain number of nodes. And so the example here is that if you have 13 nodes, you can actually have 4 nodes fail or not be able to communicate or be malicious or whatever reason, and you can still achieve consensus. Next, we have the node project, which actually wraps the plenum consensus. It also handles the NIMs, which are DIDs, and state management of the DIDs. You have the credential definitions, which are the things that I talked about, the signed schemas essentially. And then you have your schema transactions and your, not registration registries, that's redundant, revocation registries. which are basically how you say that a credential's been revoked. And then in the future, the authorization policy will be put on there as well. I believe there's proof of concept for that as well for the DKMS. Okay. It also does the validation to actually check transactions, make sure they're correct, and then it wraps quantum consensus, which is nice because if we decide to go with a different consensus algorithm, we can plug that in. And so we're actually taking a look at the potential to do that. Moving over to kind of what I refer to as the client side is the Indy SDK first, which is a standard SDK. One of the main things it does is helps you interact with the ledger, which I kind of like to think of in the traditional client-server architecture. The node is the server. The client with Indy SDK is interacting with the ledger. So it's traditional client-server to map that mental model. Comes with a general-purpose solution, which is called a wallet. It's basically a standard interface over the top of a database to be able to manage keys in a secure way. It also is adding features of agent-to-agent protocol, which is basically like the pack and unpack functionality so that I can just put a message in and it'll handle, tell it which key and it'll handle, getting that message to the right people and stuff like that. It also adds rich identity features for developers so that you can actually build your own agents. We've got reference agents in here as well. And one of the aspects of this is it's written in Rust with C callable APIs. So if you need it in a different language than what's available, you use the C callable foreign function interface to be able to call into Rust, and it makes it very easy rather than having to implement the logic in many different languages. We implement in one and just add wrappers. So moving forward to the agents, this is basically built using functionality from Indy SDK. It's also extensible using message families, and this is where you can build in your own functionality with them. The idea behind agents is essentially that you probably will only have one agent per device. And with that, you will have some way for traditional applications that are on the device to be able to communicate to that agent and to use the identity system that's built through the agent. And then last is the identity extensions, which is kind of the aspect that most people care about, which is how do I take Indy and put it in my app? And so the idea behind this is you build your own message families, which are JSON formats, how the messages will flow, what type of things you'll be signing and stuff like that. And you'll be able to integrate those directly in so that you can interact with the agent, which will then pass messages to their agent and be able to communicate to their app. And so that's kind of the idea behind it. And with all of these, you've essentially created this client-server architecture that's very pluggable so that we can switch out pieces as we need to. So one of the things that's been discussed is, changing out the consensus algorithm and changing out the crypto library, and so we can build all of that stuff very easily. We're on the demo use case, but I see there's pizza, so I will stop and give everybody a break real quick.
So based on your very first slide,
Mm-hmm.
or second slide, or third slide, or nothing's there.
Yeah.
I conclude that
Recording back here. Yeah, go ahead.
A whole lot of pizza over here. You can come over and get it if you like some. You
Sounds
move the
good.
snacks into the kitchen. You want some snacks? There's food in there. Help yourself.
Alrighty, so for demos here, the way I wanted to approach this is we've got a video first that shows a very high level. So like I said, I merged this from a few different slide decks that I had, and it works kind of as a generalized slide deck. So that's in the wrong place, that's in the wrong place, that's in the wrong, okay, I have the ordering wrong. These are all the how you contribute stuff. Sorry, I need to go in and change that. This is what I was talking about for demo use case. We've got a video here that goes at a high level, kind of how things work. I don't know how I'm going to be able to broadcast this audio out that loud.
We're going to demonstrate how verifiable credentials can be used to prove.
Can you guys hear that? I assume not.
Hyperledger Indy projects getting started tutorial.
Okay.
By building on the British Columbia government's work, verifiable
Yeah.
organizations,
I can do that. So the idea behind this is, do you know how to turn the volume up?
Is it coming from your speaker right here?
Yeah, it's coming from a speaker right here. There we go. I'm not seeing audio. I will just speak. I've done this a few times now.
Yeah, just speak.
So basically what's happening is it's walking through the getting started guide, which we're going to actually do an interactive demo with next. We've built a few different things on this use case, which is essentially Alice has been just graduated college. She's going to get a job, and then she's going to use the employee credential that she receives to then go get a loan on a house or a car. I can't remember which one.
Our persona for this demonstration.
So basically what this is introducing is what I just said. We've got Alice, and then we've got the three actors, or the four actors. We've got Alice, Faber College, which is the college she graduated from, Acme Corp, which is her employer, and then we've got Thrift Bank, which is going to actually offer the... Perfect. So what she's doing right now is she is getting her government ID, and that is her entering her information, which, again, this is a demo. She generally wouldn't enter her information to the government. They don't just accept anything. Like, she doesn't hand over what her first name and last name is. But in this example, that's acceptable. You are able to build systems where you don't have to do it that way. So she's first been issued her government ID, which is like her driver's license. And now you can see, which is what we're showing here, is basically an agent that she has a credential and it's been issued to her. So next she's going to go get her transcript credential from Faber College. And so the idea behind this is essentially she's going to enter this information. Again, the college would probably have this and already provide it to her, which does a offer request protocol rather than request offer protocol. It's basically just a feedback loop so that you can iterate and you can actually do negotiations and stuff like that. What this is showing here is the actual data that's being incorporated in these credentials. So what you'll be able to see is that, it's being issued by a particular DID. So it's actually being issued by Faber College. And then it's providing the actual data in here and specific encoding. So you can see in here, we've got Alice actually showing, and I don't think you guys can see that in the back. It says Alice, and then it also has an encoding scheme, which is basically a hash of that string. And so it's doing the signature on that stuff specifically. One thing that it is showing right here as well is that what it's doing is it's actually taking the credential that she was issued from the government ID, and it was auto-populating it. So that's why the Alice and her first name and her last name were already included in that, was because she already had a credential to be able to show that. And so what this is showing here now is that she's going to go and apply for the job. And so the government ID she already has, and the college transcript she already has. So she should be able to auto-populate a large portion of this information. And so that's what you'll see here, is that you're actually getting the social security number and the other information through a proof that she's already received. And so they will take that proof, take that information, and then use that information to then go issue a new credential. In the future, I would believe that we're going to optimize these things where no longer will you have 30 credentials with your name on it. There's some advantages to that. I think what will happen in the future is you'll actually have pieces of data that gain a reputation, which is basically my name has been signed by 30 different people, and I can go prove to you that it's been signed by 30 different people and prove that it's actually my name. So one of the things she added in here was actually her salary, and that's one of the better jokes of the video, is how often do you actually get to tell your employer how much you want to make, not the other way around. And so what you'll see here is she's actually telling them, oh, I want to make $200,000. So they're issuing her a credential that says she makes more than $200,000 with less than a year of experience. She must have a good job. Lastly, though, she's taking her 4 credentials that she's been issued, and she's going to actually go apply for this loan. And so using the agent again, she will then auto-populate all this information. And so now she's at the point where she doesn't have to fill out anything, and she's able to just submit it, and it automatically is able to cryptographically verify all this information they can receive that proof and offer her the loan. And so now what we're going to take a look at is here's all the credentials that she actually has within her agent. And so these are the types of information that she's able to use. What this is doing here is it's actually verifying the credential on the ledger. And so this is showing that functionality that I can reach out to the ledger and verify the credential. And so here is the actual credential that's being presented. And I believe there's a way that it says like verified, and it'll actually cryptographically verify that it hasn't been revoked and stuff like that. So that is that demo. And there's actually code that runs with it. That's what this link is. I have a link included as well in the slides at the very end, so that if you want to go run through that code and understand what's going on underneath the hood, you actually can. But moving forward, we will head over into the next demo. And this is a live demo. So the way I set up the slides is show the video first. Here's the link to it. And then I was going to ask questions. This is a smaller room, so feel free to ask questions as you guys go. I assume when I'm in Switzerland that it's going to be a much larger room and I won't be able to just interact in town hall format. Basel. So it's going to be at the Hyperledger Global Forum, the 12th to the 15th. Oh, thanks for making that worse.
Swiss German. Yeah, Swiss German, and it's Swiss French.
Well, I speak English, so does anybody know how to say I only speak English in both those language? What's that? All right, I guess I'm going to have to consult Google Translate. Gotcha. So what we're going to do here is the actual demo now. This is a demo that was made by Stephen Curran. And I'm getting a redirect notice. Okay. This links directly to the GitHub repository. One of the cool aspects that I want to be able to show is that you can do this demo interactively, and it can all be done in a browser. So I'm doing a live demo right now, so we're going to hope that this works properly. But the idea behind this is that I can go to, let me move this here down to the bottom. There we go. lab.playwithdocker.com. And so what this is essentially is a Docker environment built into a browser. And so a lot of these getting started guides and these demos are built around Docker. And so you need a Docker account, I believe, to be able to log in. I'm not sure if that logged me in. Yep, there it did. So now what I've got here is a Docker environment. I haven't ever hit the time limit, but I think it only goes for 4 hours where I can actually run everything in browser. And so what I'm going to do here is I'm going to add an instance. And so it's going to set me up, and I've actually got an in-terminal browser to be able to interact with. And so with this demo here, I can actually go through this agent demo script. And so that's what we're going to work on here. And so what I need to do first, let me go back to this link and grab the git clone. So it actually gives details within here about how you go and do this demonstration. You can either do it on your laptop or you can do it in the browser. I prefer the browser. It's much easier to work with. And so the idea behind it is you're going to essentially clone this repository. And so it'll clone it in here. And then now I have access to it in here. And within here, I go into the specific place where I need to, which is the education repo, then LFS 171X. So this is actually a Coursera EDU course. And then we're going to go into Indy material. And now I'm running out of space again. And so now we've got Node.js that we're going to go into. So what this is it's a Node.js agent that's been written using the Indy SDK Node.js wrapper. And so essentially what I've got here is this build script that I can run, which is, if I'll show you kind of what's going on in here. Can you guys see this too? I didn't even check about that. Can you guys see that in the back? Okay. That was the wrong approach. There's a way to increase the font size. Is that more readable? Okay. So this manage script here has a few different commands that I can run to be able to actually get things going. So the idea behind this is that if I want to run it, I can actually do .manage and then build. And what it'll do is go and build me a pool of nodes and then 4 agents to be able to actually represent all of the actors that were just shown in that getting started guide video. So I'll go and hit that. So what it's doing right now is pulling down all of these images here from Docker repository GitHub. These have all been maintained and they're being maintained by the British Columbia government. And so it's easy to update these things and be able to run this getting started guide based upon specific versions of the Indy SDK. So we'll give it a little bit of time to go through kind of what's going on. Essentially what these are is pre-configured environments, because what we found is a lot of people have troubles getting the environment set up on their host machines. And so a large portion of that comes from we're bringing in a lot of crypto libraries and a lot of other pieces that are really messy to play with. If you're on Ubuntu, it's fairly easy. Most people are able to figure it out. If you're on Mac or even Windows, it gets a lot more hairy. And so that's kind of the idea behind it. So we're going to go through that kind of environment first. And then the second demo that I'm going to show here is actually how you can run a Docker image through a browser to be able to actually build your own development environment and do it on any sort of machine. Hopefully within about the next month or two, we'll get these two merged so that you'll be able to actually work directly on an agent through a development environment where you can run it in either the browser or the directly on the machine. And then you'll also be able to build your own complete agent from the bottom up, which is the second demo, doing the same thing. And so that just basically needs some images and a few other nice things that make it work a little better. But we got this running now. So what we're going to do here is we're going to do manage, and then I believe it's up. Let's do a double check. They're actually the same thing. So we're going to do manage up. And what this is going to do is it's going to start up 4 nodes, and then it's going to start up a bunch of web servers for those agents as well. Yep. So the way this is working is, I believe you've got 4 independent Docker containers that are representing 4 independent nodes. And they're running on one. They're probably, I think how this, yeah, it's probably like one AWS server, which is probably why. Probably, I don't know how this playground, yeah.
And so those nodes are all running Docker, and they're listening to ports. And
Yep. Yep. So I'm not exactly certain about this tool itself, the Docker, play with Docker and its backend. It may actually be, that's an interesting question that I might be able to figure out. We'll jump down to Activity Manager. I can see that it's consuming about 4 gigs of RAM. So if my Chrome is consuming excessive amounts of RAM, more than like 2 gigs, like normal, it's probably doing that. So yeah, it looks like it's not running locally. This is actually being run somewhere else. So I guess I'm getting free AWS or something. I don't know. But the idea behind it is essentially I've got Docker running for 4 hours to be able to play around with it and stuff like that, which is really cool when you're just trying to play around with the Indy SDK and stuff.
So when does that 4 hour period set itself? Log in, log off?
I think so. I think the idea behind it, as I understand it, because I had like 3 hours before when I first ran this demo, is I think when you log back in, it resets 4 hours, and so it'll shut down the instance so that they aren't constantly just paying for your Docker containers. Yeah, go ahead.
When I did this demo on my box, it's not inside of a browser. All of the nodes are on my Mac.
Yes, that's a good point. So we have two different ways that you can do this demo. You can actually run it locally, or you can run it in the browser. I'm more fascinated by the browser stuff and like showing it more at talks, because what I found last time I gave a talk and showed the Indy dev stuff is everybody who was running the Windows had a horrible experience with Docker. So showing this in the browser and showing how you can set this up in the browser is actually a much easier way when you're showing to a bunch of different people who have a bunch of different environments. And so the idea behind this is, if you guys want to, you should be able to follow along and do this demo at the same time. But essentially what we've got up here is a bunch of IPs. So I'm going to open these up. So these are different agents that are talking specifically to their IP here. So you can see the URL. It says HTTP IP 172-18-0-12. So it's talking to a specific IP on their servers using a specific port. And so I can actually do that stuff. Then we've got these other agents here. I will get them opened up.
So those are IP addresses on the internet?
I guess so, yeah.
So I can write an agent rather than my local box and have it talk to these nodes that are in the Docker containers?
Yeah, I suppose so. I hadn't thought about that, but yeah. As long as you're putting your URL endpoint that you're talking with to, this specific address right here, which I'm.
We actually set that up.
Yeah.
So yesterday we actually ran
Cool. Yeah, it's supposed to show that this isn't some mythical thing that we're just waving our hands at. You can actually run these things and run the software today. Yeah. So we've got the 4 agents running, and then we've also got the Blockchain Explorer. So I mentioned the Genesis transaction file. This is actually what a Genesis transaction file looks like. It's a bunch of JSON junk with keys in there. And so that's how they actually validate the node. So when this network is set up, it sets up 4 nodes locally, generates keys for them. I believe they're actually static by setting a hard-coded seed into it. Makes it a little easier to run these environments, but in a fully secure environment like the Sovrin network, they're all managed independently. You don't share those private keys, anything like that. It's not in the code. And it actually lists the IP addresses directly in here. And so that's kind of the idea behind it. Then we've also got 3000, which is Alice's agent. So we've got, the idea behind this is that you've got 3 agents here independently, and then you can talk to Bob's agent, which is separate. And so Bob's agent is its own agent, and it should be able to talk directly between Alice and Bob and show a second demo, which is be able to send messages back and forth. And then the last part right here is the what's happening on the nodes is you've actually got 2 separate network interface cards. So you've got 4 that are running for validator pools to communicate just with validator pools, and then you've got an external port to communicate with everything outside of it. And that's until we get observer node architecture, at which point my understanding is the validator pools will only talk to themselves. And if you want to talk to a validator pool, you go through a proxy like the observer node. And so that's kind of the idea of how we prevent messages from being spammed onto the validator pool. So to go into this demo, and I'm probably going to have to rely on some people who have actually run this. I haven't gone all the way through. I've just done a few things. We've got the demo set up. So we're going to go into this agent demo script, which is what's going to tell me what I actually need to do to be able to set these things up. So The first part is it's covering decentralized identifiers, a lot of the stuff that we talked about. So we're going to jump into step 1, which is other than the colors, it's telling, okay, so it's telling you how to identify the different agents. And so I think the first thing I need to do is I need to have an interaction between Alice and Faber College. So we're skipping over government, or maybe Bob plays the government today. That would be an interesting aspect. So the idea behind it is we've got my DID here, and we're going to copy this DID. And the way that you do this right now is you'd send it over, you know, like text message, email, something like that. You'd send a DID over so that somebody else could communicate with you. Actively right now, I actually just got off a call this morning with about 20, 25 other people. We're working on how you actually set up different connections and send specific message in a standardized way so that you don't have these problems where you have to send it in these weird ways. It'll all be able to integrate in. And so we're standardizing those processes now. Yeah, go ahead.
I generate my own DID.
The agent generates it for you. Yeah. Yeah.
Me if I go.
Yeah. Yeah. Well, if you want to, so the way these DIDs are generated for this Sovrin DID method is it takes a public key or a private key, generates a public key from it, and then derives the DID from that public key. I think it takes like the first 21 or 22 bits, or what is it? You wrote this. I don't know. I'll defer to you. Yeah. How's the actual DID derived from the public key?
It is the public key.
Oh, okay.
It's just base 58 encoded.
Ah, okay.
If your keys are ever rotated, it stays spaced.
Right.
Yeah.
So I'm assuming there's some kind of a collision detection.
Not really. We just assume that the search space is so large that you won't run into that problem, assuming you're doing it properly. Yeah. Yeah, it's exactly what it is. Because this,
even bigger.
yeah, the search space of this is like the size of the entire public key space. Of
256 bits.
But you do have to give your birthday promos.
Yeah, and the odds of that are pretty
But not zero.
It's
Yeah.
not zero.
It's true.
Okay. Nothing
So, but at any rate, an agent generates its own DID and then presents it to a node and says, please identify me by this DID.
Yes. And so the idea behind it is even if you had namespace collision, you would need namespace collision on the same agent, which makes it even less likely, but still not zero. And so that's the idea behind it is I'm taking this DID here, and to do this properly, we're going to take Alice's DID, which is what I'm copying down at the bottom, and I just realized you guys probably can't see that again. Is that a little better? Can you see that? Cool. And we're going to copy that, and we're going to pass this magically over to Acme Corporation. If you're setting these pieces of software up, and when you're doing like Connect.me, which is the app in the demo that was run out at IIW, we had a request to do that, but I saw it too late, so I wasn't able to get that demo set up. You can actually do this in many different ways, where you can just do it through QR codes and stuff like that. But the idea behind it is I passed it, and I'm going to send a new connection request. Okay, so the connection request, actually I was right. I'm going to take Acme's DID, give it over to Alice, and she will send the connection request by pasting that DID in, and send that connection request. And so what we can see here is that I've now sent this over. And if we jump over to Acme Corporation and go to their messages, we should be able to see a DID request sent over. And so what I'm going to do here is I'm going to actually accept that. And so now if I look at Acme, I can see that I have a relationship set up with an endpoint DID. And I can now jump over to Alice's agent and take a look at this, accept that over here. And jump back to the relationships, and I can actually see Acme Corporation. Yeah, go ahead.
Is that relationship now stored on the chain?
For this demo, yes, because we don't have what we refer to as pairwise DIDs completely built out yet. We're in the process of standardizing that right now through the Hype, and that's under microledgers. So for this demo, we're doing that, but I expect within the next month or two, we will have progress on that. We have proof of concepts to show how you can do that directly through pairwise DIDs, and they're completely off-chain, but they're not production ready at this point. So that's the caveat to it. With this though, we're going to now do a credential. Let's jump back here so I'm following this demo properly. So we've set up the connection between Faber College and Alice. Second, we're going to post a credential definition here. So I'll blow this up a little bit more to the actual ledger through Acme Corporation. So the way they're going to do that is go into this issuing here, and this is already pre-populated with the schema information. So this is what the schema will look like. It'll have a name, a degree, status, year, average, social security number. I don't know if I missed a agent here. No, I didn't. I'm not seeing where the government agent is, so I guess I'm going to be pre-populating my own social security number. Again, the whole point. Yeah, the whole point of this is a demo to show credential exchange, not to show, here's an actual production thing. The actual production demo that was done at IW is the much cooler one, and I think I'm actually going to get that set up so that we can do that at Hyperledger. Can I coordinate with you guys on that? That's why I did this first talk here, so that I can learn kind of how I want to do this. And so I'm learning that's probably a better approach to this and more interactive for you guys. So what we're going to do here first is create this schema. So I'll submit that schema. And so now on the ledger, I've actually got transcript 1.3, which is the schema version and the name. So I should be able to jump over here to the blockchain explorer and be able to see on the domain ledger at the bottom, I should have a new schema. Let me blow this up for you. That's actually got that information on here. So I've got the attribute fields, like shown, transcript and the version. And so what was happened was it was actually signed from this DID. And so if we jump back over to Acme's DID, I believe that's the DID there, XPB, and we've got XPB. So we're able to validate that Acme is actually issuing credentials through this directly. This is correlating right here because Acme is using the same DID to issue credentials as they're using to set up. But for most public organizations, that's not a problem. Yeah, go ahead.
This creates schema. This is Alice.
This is Acme Corporation. Yeah. And so they're actually going to, and actually I just realized I messed this whole demo up. I'm supposed to do the college first, not the, the other one, but same process. What we'll do is we'll send a connection here real quick and set that up between Faber College and Alice.
So the schema that Acme put on the blockchain.
Yep.
Is the schema that says I can provide these credentials.
It's a schema that says here is a credential format.
Yes, and I can give you this data.
That would be the.
It to you, but I can.
Yeah, that would be the credential definition.
And that goes on the blockchain. It's owned by Acme.
Correct. The credential definition is the schema is usable by anybody, and so the idea behind that is we want to standardize on like traditional schemas. So you don't want 30 different driver's license formats, different fields and stuff like that. And so now we sent that connection. Let's refresh this real quick. Setting up another connection between Alice and Faber real quick. And we'll accept that there. And so now if we go back, we've actually got a connection between Acme and Faber. And Faber will have a credential. Looks like this credential was actually issued by Acme Corporation, so or the schema was. But in order to get this demo back on track, what we'll do is we'll actually use Faber College's schema. And so now we'll see that transcript 1.3 is in here. Notice one thing that just happened is I had to resubmit the schema. So there's actually two schemas just like this because this agent and the agents right now in the Indy SDK itself does not have a way of discovering schemas directly from the ledger at this point. There's ways that you can get schema layouts and stuff like that, but I don't believe there's a way that you can say, hand me back all the schemas so that I can select between them. So typically what's happening right now is you will create your own schema, issue it, or issue that schema and then hand that out through an out-of-band channel to everybody else who you want to use that schema as well. So like, for example, the credit union ledgers, one person's going to create that through their trust framework, and then they will probably take that schema and actually put it in the trust framework itself so that everybody will know that it needs to use this specific schema and stuff like that. Yeah, go ahead.
So if I understand what you just said correctly, you can't search the ledger for schemas?
At this point, that is correct, unless you are doing a lot of like out-of-band stuff. The reason for that is because, say for example, there's 1 million transactions on the ledger. For every time you go and you want to say, give me all the schemas, you're forcing the nodes to say, okay, let me go through all 1 million transactions and pick out those ones. And so that becomes very onerous very quickly and slows down the consensus of the ledger. And so we'd prefer to force people to do that stuff out of band until we can figure out a solution that's scalable.
What's your use case for wanting to find out?
Well, just if you go to blockchain.info, you can walk all the blocks in the blockchain and see all the transactions. And I was just wondering if there was an analog.
You could, and certainly we don't have the ability to create a contract. But if you have an observer node, you could do that on an observer node without a complete copy of the transaction. And so,
okay,
you know, to Kyle's point, you can imagine that somebody could run an observer node, and their whole purpose for doing that might be to provide a search directory of schemas or something else. The reason I ask for your use case is because for the most part right now, we anticipate that most schemas will be part of some higher level trust framework. And, you know, so for example, IMS Global is an already existing organization that is worried about electronic formats for university transcripts. Right, so they probably would write a schema definition for what they think university transcript should be. They would obviously publish it on their website. They have a whole way of talking about that. And that's another out-of-band mechanism for finding schema.
To your point, though, about having like blockchain.info, that's essentially what this is here. This is just connected to the local nodes. But I fully suspect once we have observer nodes, two things will occur. One, we'll get a blockchain explorer like this sitting on top of an observer node. And two, you'll be able to directly contact those observer nodes and get information about what's on the ledger rather than having to query directly to a validator node. And so one of the things that'll be cool about this is you could actually set up a scalable like AWS instance that sits in front of that observer node. And its whole purpose is to respond to all read requests at a very scalable rate. Because the actual transactions themselves are still cryptographically verified through the state proofs. So you don't actually need to run your own full node in order to solve that.
No, that makes perfect sense. Right?
Yep.
I was just thinking the blockchain.info capability.
Yep. Yeah, so that's what this is doing. So what we'll... So like what you'll see here is we've actually got 2 transactions here. So this root hash was the first one that I issued. And then if I jump down here, this is the root hash of the second one. And so you can actually verify those root hashes. And so that's why you could use an observer node to validate that this stuff's actually on the ledger. But to continue on with this demo here, we've got those credentials issued by Faber College. And now what we're going to do is submit the credential definition. And so this took a little bit longer because that credential definition is now doing some signing and stuff like that, a little bit more cryptographic intensive, I would say, but it's still not slow by any means. And that's the credential definition is done once. And so jumping back here, if I refresh this, what we'll find is at the very bottom now, we've actually got a credential definition, which is basically saying, I will issue all of this data. I will issue the average, the degree, master secret, name, social security number, that type of stuff.
Numeric value.
The numeric value here, I believe, is a blinded secret. Is that what it is? Or is it the encoding? These, in the credential definition, what are these giant numbers? I'm deferring to the crypto guy. And
Space 10.
Very hard.
Yeah.
Yep.
Right now it's RSA based.
and so
RSA signature.
yeah, so we've got a few other additional things in here as well, which are used for credential issuance. So now stepping back up, you got a question? Nope. Okay, come on. We're going to actually be able to issue a credential to Alice because we've got a relationship here, and we're going to issue my transcript. So we're going to send a credential offer. Jumping back over to Alice, we've got a message here, I think. There we go. Oh, she already had a government ID issued to her, which is that information. If anybody who's done this demo knows that I'm heading in the wrong direction, please let me know. So we've created the schema, created the credential definition, established the relationship, and now we've got the relationship here for the new one. We're jumping back down. So I jumped over a few of these steps as I was explaining these things because a lot of the steps are very similar. And there's a whole guide for this on how you do this. And so now what we'll see is that she's actually been issued a credential under, we'll see here. Faber College. No, it's not that one. Give me a second to read through this. I was so focused on the slides that I didn't get through the demo all the way. For the purpose of conserving time, because we won't be able to do this demo, what I will do is I will leave this as a project that you guys can do. There is a great walkthrough guide for this. What I want to do is I want to jump to the other demo that I actually built and show you guys how that works, because I have been through that one before, and I think that's going to be a more effective use of the time. But from what I understand, this is an effective way to be able to do the getting started guide just as well. We've had a few people already go through it here, and so I didn't want to sit around and basically waste people's time on this.
What is the Faber agent?
Between the Faber agent, it is communicating.
Is it a direct TCP connection?
I believe so. I don't know if it's TCP. It may be UDP. Yeah, it's a REST-based API, but I don't know if it's setting up actually, I know it's not setting up a TLS connection. I don't know if it's sending it over TCP or UDP. Yep. Yeah, I'd have to double check. So this is actually being built by some people at BYU and British Columbia government. They've been the ones who've been doing a lot of this stuff for this demo. But the idea behind it is you can actually do this transport agnostic. And the reason that I say it's not sessions based is because the way we're actually doing this is message based. So I encrypt a message for you and I can send it to you or to any other agent. And I can send that to you through mail. If I wanted to print it out and you wanted to type it all back in, I could send it over, you know, a more reasonable way like HTTP. You could do SMTP, basically any transport method that you want. And so that's kind of the idea behind it. Whereas when you go to a sessions-based approach using cryptography, you'll eliminate a lot of potential options for sending messages back and forth. And that's particularly important when you're trying to do offline use cases, where, for example, you're trying to validate credentials through refugees or something like that. And so that's kind of why we've taken that approach. The idea behind this is that you should be able to get all the way through that exact same video and do the getting started guide and be able to actually see the credentials that are running. But what I want to do is I want to jump to this other demo that I've set up here, which is how you can actually go and play around with the Indy SDK. So the idea behind this is, like I said earlier, it's very hard to get these things set up. And if you want to go and build your own, you run through the getting started guide and run your own how-tos. And there's actually a did-auth implementation in there now. You can actually go and see the code and work on that code directly using the Indy SDK calls. So we will head to that direction now. What we've got here, essentially what this is it's a Docker environment, and I will set this up new. Let's blow this up first. We've got, what's that? Yeah. Is that good? Cool. Okay. So we're going to create a new directory here just for this demo. So that you guys can see exactly how this is working. And so what this is, in these slides here, I've got this next link here, which is a link to a GitHub repository with a Docker setup. This is how you run Windows, but there are Makefiles built around how you run it on Mac and Ubuntu. There's also some help on how you can get Docker and Make set up on your host environment. It is possible to also get Make running through Windows, but it's more difficult, and I don't develop on Windows, so I haven't gotten time to be able to sit down and try and figure that out yet. But this is github.com, Caden Hartog, which is my GitHub name, and then Indy Dev, and it is linked to it directly in here. So you should be able to grab those slides, and I'll make sure that link's working so that everybody can grab the slides. So what we're going to do here is go and clone this. So now I'll have a new repo in here. We'll go into Indy Dev. And then what we're going to do is do a make build. And so what this is doing is it's running the build script, which actually just went and built the Docker images. It turns out I had some of these already built through my Docker. So this would have taken a little bit longer if you're doing this yourself. What it's doing is it's going and creating the Docker nodes similar to what that last demo did. And then it's creating a development environment Docker container as well. So that what we can do now is, actually I'd prefer to keep that down there. We can actually do make start, and it will start up the nodes is this first thing, what it's doing. And then it's also starting a Docker container for a development environment. And what it did is it went and mounted in that repository that I was in, the current directory, into the Docker container. So if you wanted to switch between multiple projects and run the same Indy SDK, you can actually do that. You're going to have to go and grab the specific Docker command out to be able to run that. But that's just within the make script here. So I'll show you what that looks like. We'll go into scripts here, and then I'll cat out the start. So if you take this command right here and run it when you're in the current directory of whichever project you're trying to work in, you can actually move this container over to multiple projects and run all of your stuff within the project itself and do kind of a quick iteration process. So usually what I do is I run this whole process inside of VS Code's terminal. So it's just like a normal development environment experience for me. I can actually have my terminal running a Docker container inside of VS Code, editing code directly within VS Code. And as soon as I save it, it automatically saves it to the Docker container, and I can do a very quick iterative process through that. So what I'm going to do first, though, is just kind of show kind of the how-to guides running. So what we're going to do is we're going to go into Python here, which is what the how-to guides are written in. And to show that this is actually working, let's do this. We'll go Python 3 and then getting started guide. So this is actually the getting started guide written in Python. And it'll just run through and show you a bunch of command line stuff. But what I'll be able to show you here is kind of how this code is working here in a second. I'll jump over to the VS Code and show kind of what that development environment looks like and how you can quickly iterate through it. So what I'll actually probably do when I'm showing this, after I'm done with this, is go and break it, show how it breaks it, and then go fix it and show how it fixes it and show that iterative environment. And again, the whole intention of this here is if you want to build functionality with the Indy SDK directly into your applications that you already have, you can use this environment to do that. And you can actually, because the Docker file is already in there, you should be able to just directly take the lines that are in the Docker file and move it over into another Docker container if you've already got one, or set it up inside of this Docker container as well. So you can take your dependencies, the dependencies of the Indy SDK, merge the two, and have a clean Docker container that works for your development environment. So what this is doing is it's basically printing out all the messages that are happening underneath in the Indy SDK that we're able to do it. So that video that we did in 5 minutes and the video or the live demonstration that I got about halfway through, it's the exact same thing as what this is. This is going down to the actual code layer though. And so what we've also got in here is a few other how-to guides. With all of them except for one working. The last one that's not working is this negotiate proof one. It's something that I'm trying to figure out the structure for the JSON. They changed the API a little bit, and I haven't been able to figure out the new API yet. So I just need to get a message sent over to the guys who wrote the Indy SDK so I can get the demo written in here. But the idea behind this is that if we go into 01, which is the first how-to guide, we can actually go through a process of how we're building the code. So what this is showing here is the steps of what you're doing, which is you're first going to create a document called write.did, and then you're going to start taking pieces of code that exist in these other files here, step 2, step 3, step 4, and step 5. And you will actually be able to show, or you'll be able to build this. And so one of the cool things about this is that within these files, it's actually telling you what's going on within these lines of code. And so you can figure this out. And so the idea behind this is through these how-to guides, you're building a very similar approach to what was done in the Getting Started guide, but you're building it yourself and figuring out what's actually running through the code. And this is a way to familiarize yourself with the SDK. And so just to kind of show, the other cool thing about this is we've actually got an example in here for write.did and VerdKey. So if you aren't able to figure out how to get everything built, you can actually just run this and it'll actually show you it. And so what this is doing is it's actually running through the process of getting all these steps. So it actually went and created a new local pool ledger, opened the pool ledger, created new secure wallet, opened the wallet, generated and stored the steward DID. So it's actually doing this. So this is the actual code layer of what's happening within the agents. So the idea behind an agent is you can go and build this directly into any application you want if you want. And now what I will do is jump over to VS Code because one of the things that still needs cleaned up in here is it's not deleting the wallets. Oh, well, it is deleting the wallets if it gets all the way through, but I don't think it'll run again. We'll just try it. Because one of the things it's doing is, okay, it does. If you've broken it, or if you found that your iterative process, like what you did, didn't run all the way through the script, or you didn't delete your wallet or something like that, it can pose certain problems for you if you're trying to create new pools, because what's actually happening is you're creating some files here. So I'm going to jump over to VS Code now and kind of walk you through that iterative process. And I see we're getting close to time as well. So I'm going to try and do this very quickly. So this is actually my other one here. It's basically the same thing though. It's all the same files, but it already has stuff built into it. So I'll show you kind of what's going on here. So within here, I'm going to do the exact same thing. I'm going to run manage, or not manage, make build. It's going to build them really quickly. I built the dev environment and it built the nodes. And then we're going to do make start. And so what this make start's doing, since I already have 4 nodes running from the other development environment, it actually didn't go and start another 4 nodes. I just started the development environment. And so now I've got this directly in here. So like I said in the getting started guide, we'll be able to run this. So we'll do, let me blow this up. Can you guys see that in the back? Okay. What we'll be able to do is do that Python 3 getting started guide. It'll run this time. And then if I go into the actual file itself where the getting started guide is, which is right here. And I realize it's modified, so I may have already broken it unintentionally. What I'll be able to do is I can like comment out like this line of code here. Yeah, it looks like it's working just fine. We'll comment that out, and then what I'll show you is how it breaks, and then I'll be able to rerun it again. And so the idea behind it is it's a very quick environment to be able to set it up. If you're running a web server, the idea behind it is you can run a web server out of this container, try and interact with it through an agent, see if it's working. If it's not, restart your web server, and you can test it again after you make a few changes. And so that's the idea behind it is we want a way for people to be able to very quickly get this stuff built. So now that I commented that line out, what I'm going to need to do is delete this Indy client. What this is it's a hidden file that actually contains some Genesis transaction files, basically to my local nodes. There's some code within here that's actually generating these files for you to be able to connect it directly to your local nodes. If you're running with the Sovrin network, you directly put this in to your agents. It would automatically be built in basically to your code, more than likely. And so we've got a second one here that's basically the same thing. What you'll see here is we're actually doing that to a local host over port 9702. And then in here as well, we've got the wallets, which are basically just SQL light databases. And so we've got different wallets for different people. So if I try to rerun this, it would throw some wallet errors at me because the getting started guide doesn't delete those wallets. And so what you'll have to do is delete this, and then we'll run the getting started guide again, and it'll throw an error at me this time. Or it should, if I blocked out the right stuff. Yeah, of course. So this actually won't throw an error because what I went and blocked out was a random line of code that happens to be a proof, which doesn't affect any of the other credential generation stuff. So what we'll do is go find a specific line of code that'll show how this will break it. So we're going to actually disable the wallet from being set up and show how that's not going to work. And And then we'll go back up here and down here. There we go. There's that one. Oh, okay. It didn't actually work. So I did get in there. So basically what's happening here is it was trying to run a command and it was looking for something called creds for job application proof is not defined. So I was looking for a Python variable, couldn't find the Python variable and it failed. And so what I should be able to do now is go back in here, delete this Indy client again, and rerun it and it'll run again. And so one of the things that I want to do is kind of clean up kind of these, you know, onerous things like deleting Indy client every time. I'd actually prefer to just have a piece of code that you stick at the top when you're building these development environments, and it'll automatically just delete it for you at the very beginning rather than at the end. And so there's a few other things that need to be added and stuff like that, as well as I would like to try and get this stuff built into a browser and get that environment set up with it documented to show how somebody can actually do all this stuff within a browser. And then just write your code in like Vim or something like that in the Docker container. So it's kind of the idea behind it. Does anybody have any questions? Because that was kind of the end of this demo. So. Yep, that's correct. This is just Indy-dev. I originally named it Dev Demo, and then I just renamed it when I put it up there. But yeah, it's Indy Dev. It's supposed to be a standardized development environment that you should be able to run through anything, any sort of host operating system. If you go into this, figure out you're having problems, please do file an issue against it, and I will go in and try and figure it out and add some explanations for it. So that's the intended goal of this is I recognize that a large portion of the way I look at it with this repo is my customer is an Indy developer. And so my goal is to try and make Indy developers have as easy of an experience to do this stuff as possible. So if you're running into problems, let me know. I will go figure out how to fix that. So that's what I got.